On January 21st, 1954, humanity witnessed a historic milestone when the world's first nuclear-powered submarine, the USS Nautilus, was launched in American waters. From that moment on, the United States naturally became the leader of the game and remains so to this day. Not only did it pioneer nuclear submarines, but Washington also went on to build a fleet of nuclear-powered aircraft carriers, a feat that left every other nation in awe and envy. But why is it that the United States, or any other country for that matter, has still not managed to build a nuclear-powered aircraft, even though nuclear submarines have existed for nearly 7 decades? When you hear the words nuclear energy, what comes to mind first? If it's nuclear submarines or nuclear aircraft carriers, then you're clearly a true military enthusiast. Unlike conventional submarines that must frequently surface to refuel, nuclear submarines can operate at high speed underwater for decades without needing to surface. According to design schematics and expert calculations, the new version of the Ohio-class submarine could continuously operate for about half a century. Meanwhile, when the original USS Nautilus entered service in 1954, it required nuclear refueling roughly every 2 years. The advantages of nuclear energy are undeniably clear. So why can't we create a nuclear-powered aircraft that uses highly enriched fuel to stay in operation longer? Many would immediately think of the dangers of radiation. Indeed, nuclear energy naturally emits harmful radiation. Although the fission process inside a reactor is controlled, if safety measures fail, radiation could escape into the environment, causing severe harm to humans. Yet, surprisingly, pilot safety was not the primary reason nuclear aircraft never took off. The biggest challenge was creating a nuclear engine light enough to be installed on a plane. The next hurdle was how to shield the pilots from the dangerous radiation produced by the reactor right behind them. But that didn't stop the United States and the Soviet Union during the Cold War from exploring this very idea, and even planning programs to develop nuclear-powered aircraft. When the threat of an all-out nuclear war first loomed in the mid-20th century, American engineers made some exceedingly bold plans. They proposed building a nuclear-powered airplane and recruiting back retired older pilots, reasoning that these veterans would likely die of natural causes before radiation exposure had time to cause cancer. The person who proposed this rather inhumane project was none other than Enrico Fermi, the father of the nuclear age. In 1942, while working on the Manhattan Project, which ultimately produced the 2 atomic bombs dropped on Japan, Fermi conceived the idea of aircraft powered by enriched nuclear fuel rods. After World War II ended, the United States began moving forward with plans for a nuclear airplane. From 1946 to 1961, teams of engineers and strategists produced a series of design drawings attempting to turn that idea into reality. As you may know, the advantage of using nuclear power for aircraft would be much the same as for nuclear submarines. In 1945, the War Department, now in 2025, again referred to as the U.S. War Department, believed that aircraft running on radioactive fuel could make supersonic flights around the globe a practical reality. A then top-secret document from the U.S. Atomic Energy Commission, now archived at the Eisenhower Presidential Library, stated that nuclear power might allow an airplane to complete one or several circumnavigations of the Earth before needing to land and replace the fuel rods in the aircraft's reactor. With a nuclear airplane, stops would only be necessary because the pilots were tired or exhausted after long, stressful hours of flight. Refueling would seldom be a concern. Indeed, during the Cold War era, aerial refueling was a major worry for the great powers. Bomber airframes consumed large amounts of fuel simply to reach their targets, and after completing missions, they often had only just enough fuel to return. Aerial refueling was a solution, but it was not as ideal as many assumed, especially when refueling occurred over the airspace of another country. Air defense systems would immediately lock onto such aircraft, and both planes involved in mid-air refueling would have to escape the targeting range of enemy fighters and ground-based air defense systems. High-altitude refueling often failed and could even jeopardize the original mission. To minimize the need for aerial refueling, the United States had to buy or lease an extensive network of air bases around the world. These bases were typically located very close to Soviet territory at the time, allowing bombers to cover shorter distances before reaching their targets. However, this approach was costly. There was even a time when the United States was prepared to spend $100 million in pure gold to purchase Greenland from Denmark to build an American military base there. $100 million US. Just imagine how much that would be in today's money. It was clearly a substantial sum, but surprisingly, the Danes, keeping their cool, turned down the lucrative offer. As we all know, a single nuclear-powered aircraft could have theoretically solved all the limitations of flight range for humankind. Yet that didn't mean it came without flaws. Flaws that gave engineers endless headaches. The first challenge was that the nuclear reactor on a plane would have to be much smaller than one on a submarine. And to operate effectively, it would need to generate even more heat than usual. Excessive heat could cause the reactor to melt down, spreading throughout the aircraft. Just one accident could turn a nuclear-powered plane into a massive, molten, radioactive metal projectile, plummeting to Earth. The second problem was how to shield the pilots from the dangerous radiation produced by the onboard reactor. In nuclear power plants or submarine reactors, the core can be surrounded by thick concrete walls for protection. But that kind of shielding is impossible on an aircraft. Heavy lead plates could provide protection, but they would also make the plane significantly heavier. That was hardly feasible for fighter jets, which require the lowest possible weight to maintain agility and maneuverability. Engineers hypothesized that if a nuclear aircraft had no conventional fuel tanks, the saved weight could instead be used for radiation shielding. The United States spent 16 years trying to turn that hypothesis into reality, but without success. The Soviet Union faced similar difficulties in tackling these challenges. Additionally, since nuclear fuel materials produced by various countries at the time varied greatly in quality, it was difficult to maintain stable and efficient reactions. The obstacles were immense, and you might be thinking, how could anyone possibly build a functioning nuclear-powered aircraft under those conditions? Yet, in 1958, an article in Aviation Week reported that the Soviet Union was testing the world's first nuclear-powered aircraft. However, U.S. President Dwight D. Eisenhower calmly dismissed the report as inaccurate. It was quite simply a matter of national pride. Why? A Soviet engineer who worked on the nuclear aircraft program later explained, "If we truly had such an aircraft operating successfully, why wouldn't we proudly showcase it to the whole world instead of keeping it secret?" A fair point, but I believe that magazine may have been right after all. That's because the Soviets had indeed modified a strategic bomber, the Tu-95 LAL, equipping it with a nuclear propulsion system in the spring of 1961, something that could hardly escape the scrutiny of rival intelligence agencies. From May to August 1961, the Tu-95 LAL, fitted with a nuclear reactor, completed a total of 34 test flights, with crews consisting of pilots, engineers, and technical experts. Test results showed performance that exceeded expectations, but numerous technical problems remained. The aircraft was too heavy, continuous flight endurance was far from ideal, and most importantly, protecting the crew's health from radiation exposure proved extremely difficult. In the end, like many other experimental aircraft, the nuclear-powered Tu-95 LAL was placed in storage, and in the early 1970s, it was transferred to the Moscow Aviation Institute, MAI. After its reactor was removed, the aircraft was repurposed for training. One might assume the Soviet Union was the only country daring enough to conduct such risky experiments. But in fact, the Americans had already done so before them. Indeed, the United States actually developed a nuclear-powered bomber as early as 1955 in the form of a test aircraft called the Convair NB-36 Crusader. This bomber carried a cooled nuclear reactor capable of producing 1 megawatt of electricity, hung directly in the aircraft's weapons bay and able to be lowered through the bomb bay doors into shielded underground systems between flights. In theory, a nuclear-powered bomber could remain aloft for weeks at a time, or longer, and reach any target on the planet without needing to land or refuel. Keeping an aircraft airborne for weeks may sound pointless, but don't underestimate it. During the Cold War, specifically from 1960 to 1968, that was exactly what the US was doing. At that time, the Americans had 3 B-52 bombers equipped with nuclear power on 24/7 alert, flying over the Atlantic Ocean, the Mediterranean Sea, and the Pacific near Alaska. They required minimal logistical support and landed only when the crew deemed it necessary. In the early 1950s, such a bomber was a perfect strategic asset. But do you know what the common problem was across the projects of both rivals? Neither country could solve the challenge of shielding the crew while optimizing aircraft weight. Moreover, the development of intercontinental ballistic missiles, ICBMs, in the 1950s made manned, nuclear-powered long-range flights largely unnecessary. Essentially, ICBMs are ballistic missiles with ranges greater than 5,500 kilometers, designed to carry multiple nuclear warheads simultaneously. Because of their long range and large warhead capacity, these missiles are typically deployed on submarines and ground-based silos. They represent the most destructive forces in the event of an all-out nuclear war. Unlike tactical ballistic missiles under 300 kilometers, short-range ballistic missiles under 1,000 kilometers, and medium-range ballistic missiles under 5,000 kilometers, intercontinental missiles travel much faster and much farther. They had only one purpose: to destroy their targets. Unlike airplanes, they didn't need to return, and since they had no pilots to shield from radiation, they were far more efficient from a military strategist's perspective. The nuclear aircraft development programs gradually faded away. By the late 1950s, President Eisenhower's administration had already begun cutting funding for the project. On the other side of the Iron Curtain, Nikita Khrushchev made similar decisions. By 1961, both the US and the Soviet Union had completely abandoned their nuclear aircraft programs. But the story didn't end there. In one final attempt to make nuclear-powered flight feasible, strategists turned to their last resort, using elderly pilots. The logic was simple. These older pilots would likely die of natural causes before radiation exposure could cause serious harm to their bodies. This way, there would be no need for heavy, complex radiation shielding inside the aircraft. Yet even this seemingly practical but inhumane approach couldn't save the nuclear aircraft program. The US government ultimately deemed the project unnecessary, extremely dangerous, and prohibitively expensive. As a result, on March 28, 1961, President John F. Kennedy officially canceled it. Since then, the idea of a nuclear-powered airplane has resurfaced from time to time, but it has always been met with indifference. Today, even though air power remains a cornerstone of modern warfare, the presence or absence of nuclear aircraft no longer defines the face of war. But imagine this: if the US, Russia, China, or any other nation were to succeed in creating a nuclear-powered fighter jet, how drastically would it change the balance of the battlefield? Feel free to share your thoughts in the comments below, and don't forget to subscribe to KyHuynh Insights for more fascinating explorations like this one. For now, thank you for watching, and see you next time.